Okay, hello everyone, and welcome to this forum on sustainability organized by CellPress. In the next hour or so, we will discuss the challenges and opportunities in mitigating the impacts of droughts on water resources and human societies. My name is Camilla, and I'm editor at iScience, CellPress's interdisciplinary journal. Behind the scenes today are also my fellow editors Abby Kelly from One Earth and Lu Liu from Star Report Sustainability. Just quickly, in terms of the format, following this brief introduction, I will invite our keynote speaker, Bridget Scanlon, to share her thoughts. Then I will invite our panelists, Chris Funk, Laksan Namo, Maria Ruska, and Roman Hoffman, to talk about their research areas. Following the talks, we will have a panel discussion and a Q&A. Before we begin, I wanted to highlight CellPress's portfolio of sustainability-related journals. Besides One Earth, Sun Report Sustainability, and iScience, several other journals frequently publish sustainability-relevant content. For this forum, we've put together a collection of relevant articles which you may be interested in taking a look at. You can find the link to the collection in the resources tab on the right-hand side of your screen. Sustainability research is challenging and exciting also because of how interdisciplinary it can be. Addressing how droughts impact water security, for example, requires not only understanding how a changing climate is impacting on drought occurrence, but also how this impacts water resources and contributes to community vulnerability and capacity to adapt. This is why we began the CellPress forums on sustainability. We hope to bring together scholars with complementary expertise and spark conversations on the complex challenges of navigating a more sustainable path forward. Before I hand over to Bridget to open the forum, I'd like to mention some logistical details for our audience. On the right of your screen is a Q&A chat. We encourage all audience members to ask questions for the speakers or to upvote questions from others. Our behind-the-scenes team will be adding links to references if relevant, and also just keep an eye and moderate the Q&A chat. So without further ado, I'd like to introduce our keynote speaker, Dr. Bridget Scanlon, who is a research professor at the University of Texas at Austin. Her research focuses on the impacts of climate variability and land use change on groundwater and water resources in semi-arid and arid regions. Bridget's research spans local to global scales, addressing the sustainability of major aquifers and river basins worldwide. She also hosts the Water Resources podcast, which explores water challenges related to climate extremes and human activities and highlights solutions. So over to you, Bridget. Please share your slides and go ahead.
Thank you so much. I really appreciate the opportunity to talk about droughts and water resources today, and I'm also going to discuss some potential management solutions to these issues. And so some of the key messages I would like to put forward is that we are very familiar with meteorological droughts, which is when we have low rainfall and high temperatures increasing ET, and also agricultural droughts where the soil moisture is low. Or hydrologic droughts where reservoirs are low. But anthropogenic droughts is a concept that Amir Agakuchak and others have put forward to indicate places where we are overexploiting water resources, such as overpumping groundwater, and this can continue even when we don't have meteorological droughts. Groundwater is often turned to when we're in a drought, such as Cape Town or Sao Paulo or these cities. They start drilling a lot of wells, and so groundwater provides a buffer during these drought times, and so important to understand its potential. There are key areas or hotspots where we've been overexploiting groundwater for many years: Northwest India, North China Plain, and other regions. But there are other areas, such as the Sub-Saharan Africa, where groundwater is underexploited, and the World Bank is promoting expansion of groundwater use in those regions. It's very important to understand what's causing water storage changes in different regions globally, whether it's climate or human management or a combination of these, because if we want to develop appropriate solutions, we need to understand the causes of the water storage changes. And so I'll just give a couple of examples of that: Sub-Saharan Africa and managed aquifer recharge. So on the left here, you can see the various types of droughts that different people in this present webinar series will be talking about. And on the top, you can see the meteorological droughts, and then below that, agricultural droughts, mostly from soil moisture deficits, and then hydrologic droughts from reduced stream flow or reservoirs. And then we have a number of different indices to represent droughts, such as the Palmer Drought Severity Index, Standardized Precipitation Index. And some people emphasize that these indices emphasize the drivers of drought and don't incorporate the impacts of drought. And so it would be important in the future to develop impacts indices that incorporate both the drivers and the impacts on drought. So we're very fortunate that NASA and the German Space Agency launched the original GRACE satellite mission, Gravity Recovery and Climate Experiment satellites, in 2002. And we've been monitoring total water storage globally since that time, and they provide data at monthly timescales. So here you can see a map of global water resources, changes in water storage from 2002 through 2021. And the red areas are where we've seen long-term declines in water storage, such as the Southwest US, Northeast Brazil, Middle East and North Africa, and North China Plain as some examples. And the blue areas are where we've seen increases in water storage over that 20-year time period. So Northeast US, the Great Lakes region, much of sub-Saharan Africa, increasing storage, and then some parts of Peninsular India and some parts of China. So we have different things going on in different regions globally, and it's great to have this picture from the satellites of the global status. And so here you can see so here you can see changes in water storage in different regions. So this is sub-Saharan Africa, the Kalahari region. So increasing total water storage from GRACE and peaking around 2012, representing a wet period related to increased rainfall in this region. And then this is followed by dry conditions related to climate in sub-Saharan Africa. So in this region, there's very little irrigation, so it's natural variability in response to climate. In Saudi Arabia, then we're seeing declining total water storage over the long term. And this is attributed to human intervention irrigation. And you can see the irrigation circles expanding. This is 2000, 2012, related to groundwater abstraction for irrigation, decreasing storage. So these are two end members, natural climate variability and human water use impacting water storage. So now looking at some time series then of total water storage in different regions. So the red time series in the top left here is the Central Valley in California. And you can see declining storage during droughts and rising storage during wet periods. So a lot of interannual variability. And the St. Lawrence, the Great Lakes region, increasing water storage during a recent wet period from 2013 to 2020. In the Middle East and North Africa, it's mostly declining water storage because these are large aquifers and there's very little recharge. And so a long-term decline in water storage over this time since 2002. And the largest declines in storage that we have seen globally are in the Ganges, Brahmaputra region related to irrigation and groundwater pumpage, and also neighboring Indus and also in the North China Plain. So these are just some examples of the interannual variability in storage related to climate and human water use. So the World Bank put out a report a couple of years ago titled Groundwater's Climate are the Hidden Wealth of Nations, Economics of Groundwater in Times of Climate Change, and acknowledging that groundwater provides a buffer to climate extremes and multi-risk insurance. So there's a lot of concern about unsustainable groundwater depletion in many regions, but in sub-Saharan Africa, many of the aquifers are very small, they're basement aquifers, they're local and shallow, and so they're self-regulating, and so there's really not that much to overexploit, and so they will have to be managed sustainably because they self-regulate. And so the World Bank, in their report, emphasized that we need to expand groundwater use in sub-Saharan Africa, both for drinking water and irrigation. And on the left, you have the aquifer types, and then the probability of depletion, with the blue low probability and the red areas showing high probability, for example, in Saudi Arabia and other regions. So in the US, we've done a lot, the USGS and other groups, the Geological Survey, have done a lot of work on water storage and aquifers. And here you can see the results from GRACE data over a 15-year time period. So about 30 cubic kilometers depletion in the Central Valley in California. That's about 30 million acre feet also. And in the High Plains, another major aquifer, decreasing storage in the central and southern High Plains in Kansas and Texas, and increasing storage in Nebraska. And the Mississippi is also another area where there's a lot of irrigation, but very little change in storage. So it's great to get these regional pictures from the satellites. And if we look then at the relationship between the time series of GRACE data and the US Drought Monitor, you can see for California then increasing storage during wet periods and decreasing storage during drought. For example, 2012 through to 2017 in California, exceptional drought. And then the meteorological drought ended with a family of atmospheric rivers that resulted in flooding and landslides. So the challenge is managing these extremes. And so a high correlation between the GRACE water storage and the drought data indicating climate is a major driver of water storage in Central Valley. And then in the Northern High Plains, also a fairly high correlation between the GRACE data and the US Drought Monitor, 0.7 correlation coefficient. But a much poorer correlation in the Central and Southern High Plains because there's very little recharge and they're basically mining the groundwater. And so it's basically reflects water use. And then in the Mississippi, this is in the humid region of the US, the droughts are much less intense and the correlation is moderate. So you have varying different regions responding to climate in different ways. The other major driver then is water use, and irrigation is the elephant in the room, accounting for about 70% of global water consumption globally and also in the US. So here are the major irrigated areas, the Central Valley, the High Plains, and the Mississippi embayment region. So if we're looking at the impacts of human intervention in the Central Valley, then this is the water use. So in 2010 was a wet period, and this bar graph shows the light blue is surface water irrigation, and the darker blue is groundwater. So during a wet period, 70% of the irrigation comes from surface water and about 30% from groundwater. Then 2015 was the middle of the extreme drought, and about 70% is coming from groundwater. So they switch from surface water to groundwater during drought, and that amplifies the effect of drought in California. So human water management then amplifies the effect of drought. In Mississippi, then they pump more groundwater for irrigation to support agriculture, as you can see when you compare the dark blue bars relative to California, but they're not depleting the groundwater because most of that groundwater is coming from capture of surface water in this humid region. And so how can we deal with these extremes then? So one way is to store excess surface water in groundwater. So for example, in the lower Colorado River Basin in Arizona, you can see the Colorado River on the left-hand side in blue, and the Central Arizona Project, CAP, which is an aqueduct that takes water to this Phoenix and Tucson, these regions. And so they continue to pump groundwater, but they replenish the groundwater with the Colorado River water through managed aquifer recharge and these spreading basins. So that's one way of trying to manage these extremes, storing the flood water and the excess water in groundwater for use during drought. And I recently started a podcast series because I felt like nobody was reading papers. And so one of the early people who was interviewed was Chris Funk, and he's going to be the next speaker. He was talking about drought forecasting in East Africa. And another podcast is Paul Bowman, where he uses geophysics to explore for groundwater in sub-Saharan Africa. So just to go back to the main messages then, anthropogenic drought is very important, and we don't oftentimes think of it, where we're overexploiting water resources. Groundwater is a huge buffer and can provide, help us during drought times, but there are some regions that are overexploited, but other regions like sub-Saharan Africa where we could expand groundwater use. And then if we understand the drivers of storage change like climate or humans, then we can develop appropriate solutions. So for example, expanding groundwater use in sub-Saharan Africa to deal with these climate extremes, and storing water in other regions where we have times of excess and drought. Thank you very much.
Thank you, Bridget, for starting the forum with such a great talk. And thank you as well for introducing the next speaker for us. So next up is Chris Funk, who is the director of the Climate Hazard Center at the University of California, Santa Barbara. His work focuses on developing improved early warning and climate hazard systems to support famine prevention. So Chris, over to you.
Okay, thanks very much for that introduction. And I'm Chris Funk. And I thought I would start my talk with a figure from a paper that we just published in Nature, led by Solomon Gebrechakos. And what we're looking at here is a time series of global area and drought back from 1900 up to 2022. And the red time series is a really high quality time series of drought area generated by combining 4 different data sets. And if we focus on the change between 2018 and 2022 and compare that to the previous 1981 to 2017 period, we found a 74% increase in the global area and drought, up to about 30%. So, that's a really big change. And now there's many areas in the world that are in drought frequently. And the year 2022 was really exceptional. It was record breaking. Again, with 30% of the land area affected by moderate to extreme drought. And we were able to separate the contribution of precipitation and rainfall from the contribution of atmospheric evaporative demand, and found that about 42% of that drought increase was due to increases in temperature and atmospheric evaporative demand. So it's really important that we all understand that warmer air amplifies droughts by holding more water vapor. We have nitrogen and oxygen molecules that make up most of the atmosphere, and in between them, we can find water vapor. But as the air warms, it has more ability to hold water, and this can amplify its ability to suck moisture out of plants and soils. So we can measure that with vapor pressure deficits, which are the difference between how much water the atmosphere can hold at 100% relative humidity compared to how much water the atmosphere actually has in it. And we produced this time series yesterday, which is up to date through May, and this shows January to May global average vapor pressure deficits from 1980 to the present. And so you can see that there's a big tendency to increase over time. And in fact, 2024 and 2025 were substantially higher in terms of atmospheric evaporative demand, even than, say, 2022. So this is, a big stressor on the globe. Here's another figure from our paper, which is showing the frequency in terms of months per year of droughts averaged over South America, Africa, Australia, Europe, Asia, and North America. And the yellow time series is the observed frequency of droughts, and the blue time series are the frequency of droughts if we kept atmospheric evaporative demand constant. So in a sense, the difference between those two time series is a measure of the effect of the warming atmosphere and climate change. So you can see that there tend to be big increases and really intense droughts in the latter, period. And to kind of help us understand, what these droughts do on the ground to our ecosystems and people, I just overlaid, some of the extreme droughts in 2022 in most cases, and in 2019, 2020 in Australia. So, in the Amazon basin in 2022, river levels were super low. Wildfires were very, expansive. This, of course, is a really critical part of the planet for drawing carbon dioxide out of the atmosphere. Something that I work with a lot is drought in Eastern East Africa. And between October, November, December of 2020 and OND of 2022, there were 5 droughts and massive food insecurity. More than 9 million livestock died. And in Australia in 2019, there was huge wildfires associated with their Black Summer. And then there were serious droughts in Europe and North America and Asia in 2022 as well. So these are really having a big on-the-ground impact. I work with the Famine Early Warning Systems Network, which seeks to anticipate and counteract the impact of droughts in very food insecure countries. And one of the things that we're facing is a big increase in the number of very hungry people on the planet between 2017 and 2023. But there's a silver lining, in a sense, is because we are identifying where these very hungry people are, and in many cases, getting them life-saving humanitarian assistance. One example of that, as I already mentioned, were the droughts over the 2020 to 2022 period. This was a multi-year La Nina, and there were just many droughts, one after another, that pushed millions of people into extreme food insecurity. This is a food insecurity map from February of 2023. But something to think about is that every place that there's an exclamation mark on this map are places that would have been, according to the food security analysts, one category worse had they not gotten humanitarian assistance. So in southern Ethiopia, in portions of Somalia, there were food emergencies, but without humanitarian assistance, there likely would have been famine. So anticipating droughts helps us keep famine from happening. But of course, it's a very serious concern. So another example of a drought forecast was from last July. I produced this figure, which basically suggested that because of La Nina and forecast for Indian Ocean dipole, this region was likely to suffer another drought again in October, November, December of 2024. I jumped on a plane. I went through the riots that were going on in Nairobi, met with climate experts there. And in early August, we worked together with a lot of agencies to produce this alert suggesting that in October, November, December of 2024, yet another drought was likely. It turned out that that season, while not having a devastating drought, was not good for agricultural production and pastoral livelihoods, such that in early 2025, once again, we were looking at a pretty dire food security situation, but at least we had been forewarned. So if we just take a quick snapshot of the vapor pressure deficits for October of that year, we can see that, this kind of increasing atmospheric evaporative demand is exacerbating low rainfall amounts and amplifying droughts. But it's important to realize that we are not powerless in the face of these shocks. So for example, Plant Village, which is a group that does agricultural advisories and interventions, piloted the digging of these zai pits in eastern Kenya, in Kilifi, and put biochar in the soil, which retains soil moisture. And as you can see in the upper right of that panel, the crop that had this water retention practice did much better than the maize crop on the left, which was a failure. There are also interventions like micro irrigation that can be used. And so, if we have an advance notice, there are some things that we can do to offset drought for crops. So this is my last slide, just suggesting that collaborative early warning systems can transform global forecasts into local responses. And we're partnering with groups like the Kenya Meteorological Department to help them get out effective county level advisories and farm level actions and adaptations. Thank you very much.
Thank you, Chris. It's great to hear about your work on early warning systems. We now carry on the topic of agriculture with our next speaker, who is Loxon Namel, who is a research manager at the Water Research Commission in South Africa. Loxon has over 20 years of experience across South America, Europe, and Africa, and his expertise includes agricultural water management, the water energy food nexus, and adaptation to climate change. Over to you, Loxon. You might be muted, Loxon. Sorry to interrupt.
Okay, let me check. Can you hear me now?
Yes, we can. Thank you.
Okay, thank you. Yeah, thank you for the opportunity. And yeah, I'm going to dive straight into my presentation, which I titled The Transformative Approaches, a Pathway to Inclusive Climate Change Adaptation. Right, the reason why I chose that title is because we need to transition from the current linear approaches towards secular approaches, because the challenges related to climate change do not affect one sector, but they are cross-sectoral, and they affect every sector, every field that you may think of. For example, the slide that we are seeing there, we modeled changes in rainfall totals in South Africa from 1950 to 2020. As you can see, from 1950 to around 1980, there was a lot of rainfall, but the totals decreased immensely from the 80s to the present, and the intensity of drought and extreme weather events is increasing as we speak right now. Our coastal provinces are facing severe droughts, and we have lost almost 5 lives already in KwaZulu-Natal and the Eastern Cape. And yeah, this is resulting in the degradation of ecosystems, affecting agriculture, energy, and food resources. And the question is, should we continue with the same experiments or with the same models, and we expect a different answer? Okay. This one is another, it is almost like the previous standard precipitation and evaporation index that we used for South Africa. This one is almost the same thing, but we took it for the whole Southern Africa region. where we can see modeled from 1960 to around 2010. And you can see the region is getting drier, rainfall is decreasing with the severe consequences that include worsening water and food insecurity, as well as regional instability and vulnerability. It is causing a lot of tensions, and as a region, most of our resources are transboundary in nature, and the region has formed transboundary water commissions. For example, the 8 countries that share the Zambezi, they formed the ZAMCOM, which is the Zambezi Water Commission, and where their policies and the countries that share these resources try to come out with the common policies and common goals. We know with water, it can cause, someone is moving my slides. Someone is moving my slides. I don't know, they are moving on their own. Okay, let me try to control. Okay, this other slide is also on aridity. It's causing aridity in the region. The region is getting worse and worse and more arid, affecting climate-sensitive sectors of agriculture, water, and energy. Right. Now, I posed the question on the first slide. Should we continue with the same experiment and we're expecting different results? The answer definitely is no. We have to change the way we do things, and we need to embrace the new norm. But there are 4 themes, I call them themes, that we need to think of. These are the drivers of change. What is causing the change? We need to go to the background. And with these changes, what is the risk? And how are we exposed as human beings? And how do we prepare and recover? And how do you adapt and become resilient? With the drivers of change, the population is increasing. By 2050, we're expected to be more than 9 billion. There's rapid urbanization. There is need to increase agricultural production, destruction of forests, and resulting in the destruction of the natural habitats, causing animals to come down to live with human beings, endangering, causing zoonotic diseases. Those are some of the issues that we need. So we see these challenges, the grand challenges, they are cross-sectorial. They do not affect one sector only. I'm not going to draw much on the drivers, but what is the risk? I'm going to give an example of what is happening in Southern Africa. Southern Africa, by 2050, will only be able to provide 13% of its food requirements. So where is the other 87% going to come from? And by 2050, there is going to be a 15% decrease in yields. So should we continue receiving aid, food aid from other countries? And do those other countries have those resources? We know what is happening. The global change is not only happening from the scientific perspective, but also from the political. You know what is happening. And you can also say South Africa first. And this is happening, is going to happen. For me, people, with the disclaimer, we have reached the threshold. There's no more mitigation. We just need to adapt and become resilient to the current challenges that we are facing. And these decreases in yields is already affecting 60% of the population of Southern Africa that reside in rural areas. And on the energy sector, about 45% of the people in Africa have no access to clean energy. This translates to 600 million people as it stands now. And currently 75 to 250 million people live in water scarce areas. And it is projected that by 2050, between 350 to 600 million people in Southern Africa will be living in water scarce countries. So these challenges, this is how we're exposed. These are risking livelihoods, human and environmental health, and sustainable development. So what are we saying? How do you prepare and recover? We need to transition from linear approaches to transformative or secular approaches. what do we mean? For example, One Health, I spoke of zoonotic diseases. We need to embrace One Health. Nexus planning, the justice transition, the circular economy, and so forth and so forth. These would transition into water, food, security. Why am I emphasizing on water and energy and food? These three sectors are both culprits. The grand challenges that we're facing today as humankind are the results of water, energy, the changes that we have effected on water, energy, and food. And the same sectors are also the same culprits. And what happens in ecosystems, environment, they are just trade-offs, but they are also synergies. We need to make sure that we become resilient and become adaptive. You can see the diagrams here. Our southern coast, our coastal areas, we're having floods as we speak in South Africa. It's very cold. I think you can see the jacket I'm wearing. It's extreme weather that we're experiencing in South Africa. Addressing climate change impacts requires integrated and transformative approach as climate challenges span multiple sectors. And linear approaches to climate change to adaptation and resilience only compound existing challenges. We need to change, and the time to change is now. Otherwise, if we continue with the business as usual, the consequences could be dire. And transdisciplinary, why am I advocating for transdisciplinary and circular approaches like the water, energy, food nexus? Because they provide pathways for adaptation and resilience. And on the table, I'm not going to go one by one. There are quite a lot, but I've provided some of the innovative climate smart resilience practice that can be adopted as informed by transformative approaches. For example, we need to embrace climate smart agriculture, reduce greenhouse gas emissions from agriculture, from mining, from energy, then conserve the forest cover, resources sufficiency practices, then innovative water management practices. I think this one is my last presentation, and I say thank you.
Thanks, Laxon. That was a great call on the urgent need for cross-sectoral interventions and approaches for adaptation. So thank you very much for this. Just as a reminder to our audience, please do use the Q&A chat on the right-hand side of the screen if you have any questions you want to raise to our speakers. So we're now diving more into the topic of water insecurity, politics, and water justice with our next speaker, who is Maria Ruska. Maria is a senior lecturer in global development at the University of Manchester. Her research focuses on the urban implication of droughts and water insecurity, particularly in relation to water supply systems, governance, and the politics of adaptation in cities. Maria, over to you.
Thank you very much, and hello to everyone. Thank you for inviting me to this seminar, really interesting. I wanted to start with this map to highlight first the scale at which I'm working at, which is the city scale, and emphasize the importance of cities in when it comes to thinking about resilience and adaptation to droughts. These are only a few of the cities that have experienced water crisis related to droughts over the past 20 years. There are over 80 cities that have experienced severe challenges with water supply, and the expectation is that these challenges might increase where droughts are becoming more frequent and intense, but also due to increases in population and water uses in the city. And so therefore I would like to focus on this dimension of drought and the politics of water insecurity, emphasizing that in many of the cases, both in the global south and global north, we see that those who are socially, politically, and economically more marginalized are likely to be also more vulnerable to these droughts. And this is why I chose this title for today's presentation, Don't Blame Climate Change. It is a bit of a provocation, and of course I don't mean to say that the physical dimension of climate change is not important or is not essential, an essential and critical challenge for humanity. But I want to emphasize that the physical elements of droughts alone does not explain why there are so uneven outcomes in terms of vulnerability to droughts and ability to respond and to adapt. And to do that, I will focus very briefly on a few key concepts from the social science and from particularly human geography and critical water studies around the idea of the social production of water crisis and water insecurities, to emphasize that underlying the way the outcomes of drought are distributed across individuals, social groups, and also different spaces in the city is also determined by power relations that shape who makes the decisions and what decisions are made when it comes to water management, who benefits from these decisions and visions about economic and water development, and who instead is more at risk and more vulnerable also because of a certain way of managing water. And talking about social production means indeed recognizing that water insecurity and water stress is also always due to social, political, and cultural processes. And it's not just a mere academic debate or a debate about what the most appropriate concept is. The reason why so many social scientists and critical scholars insist with these ideas is that without recognizing the role of these economic processes, social processes, and political processes, policies and responses to droughts might reproduce very unsustainable practices and very unsustainable ecological processes, as I hope to show you in this brief presentation. And so to do that, I will use a water justice lens, thinking about water insecurity from drought, from a water justice perspective, and I will particularly focus on three aspects of water justice. The first is a distributional justice, which has to do with the politics of distribution of water. For example, who gets how much water and what quality of water in the city, but also with the distribution of risk, who within these configurations of water governance is more at risk from droughts. And in this presentation, in these debates around distributional justice, infrastructures plays a very important role, as we will see in part also in the rest of the presentation. But you can imagine, if you think about cities in the global south, there is a difference from in receiving, being supplied water through an in-house tapped connection or having to access water through wells or through water kiosks. So there is a politics of water also there, which is sees infrastructure as the mediating tool. Procedural justice instead has to do with participation, so it deals with questions of who participates in water governance and who participates in shaping how proactive measures are taken to avoid drought-related water crisis, but also what measures, who participates in the decisions on what measures are taken in response to droughts, so more reactively. And so there is a big debate around the fact and recognition that those actors who are usually excluded from decision-making processes and that are excluded from these governance decisions are more likely to be at risk of droughts, because the decisions that are taken do not necessarily represent their needs and concerns. So participation, not only sitting at the table, but also setting the table, so to speak, is important to ensure more inclusive and solutions to droughts in the city and beyond. And when I say sitting at the table and setting the table, I refer to a critique of having sometimes actors involved who sit at the table but are really not given any decision-making power. So procedural justice means truly meaningful participation, where different ways of knowing droughts, different experiences of droughts are taken into account. And this also overlaps and relates to the next dimension of recognitional of justice, which is recognitional justice, which has to do with water insecurity being also a consequence of the failure of recognizing historical and persisting experiences of marginalization and inequality, not recognizing that many vulnerabilities in terms of exposure, but also adaptive capacity to respond to droughts are also historically and contingent and needs to be recognized and addressed. So in the last second part of this presentation, I will discuss these three dimensions in relation to the drought in Cape Town, a drought that is probably familiar to many of you. And of course, we have already heard in the previous presentation about extreme weather in Southern Africa. And in this slide, you see two images of the same dam, one of the 6 dams that supplies water to Cape Town, and you can see how it has changed between 2014 and 2018 after 3 years of below average precipitation. And this indeed has created significant challenges for the city. Many of you will be familiar with the notion of day zero, which was this dystopic day in which the city of Cape Town was going to be out of water, and the water utility would have to shut down basically its supply. In the end, a range of measures were undertaken, and which reduced water consumption, and the crisis was averted. But of course, there are many lessons to learn from what happened in Cape Town. So I won't go much in detail in that, because it's just to give you a sense of what happened in those 3 years. You see that on the left, the consumption, and you see the number of measures that are taken to reduce consumption from 2015 to 2018. And what the panel on the right-hand side emphasizes is that these measures become constantly more stringent and more strict in terms of the levels of water consumption, in terms of what uses are allowed of water, and which uses, for example, water in the gardens are not allowed, and so on and so forth. Fines for overconsumption and increases of prices are some of the measures that are taken to try and manage the demand in terms of reducing the demand of water, of course. And so what I think is quite interesting about the drought in Cape Town is that there is this idea in the media, also Al Jazeera in this case, that everyone in Cape Town can be left without water, and therefore that everyone in Cape Town is equally exposed and equally vulnerable to the drought. And that's probably also because it is probably the first time you see this reality of white people going to water fountains to collect water, a reality that is very common for many Black people in Africa, for indigenous populations in Africa, but not so really common for white people. And I think that created a bit this image of or the sense that the drought was equally experienced by everyone in the city of Cape Town. But this doesn't really account for the different adaptive capacities and resources that different social groups have in terms of responding to the drought. As we all know, Cape Town is a very racialized and very unequal city, and different households, different individuals entered this water crisis with very different water usage to start with, and very different ability, financial and also in terms of other capacities to respond to the drought. And this is what I will show in the next slide, discussing issues of distributional justice. So what you see on the left is a map of Cape Town, where you can see that there is areas with high to very high socioeconomic index, and then areas with low to very low socioeconomic index. And what you can see on the right is that this socioeconomic index is reflected in very different levels of water consumption in 2015, before the beginning of the water crisis. And whilst there is this idea that everybody was equally affected, a qualitative study conducted by Elisa Savelli in 2019 shows that the experiences of drought was very different for different socioeconomic groups in the city. And for example, if you look at the highest water consumers, indeed, they were the ones that had to reduce their consumptions more significantly because it was extremely high before the drought. But what you see is that many of them were able to install their own systems, which could be use of groundwater, which could be rainwater facilities, because they have the financial resources, but also the space, the yards to actually build these facilities. For middle-income people, there were other measures, for example, stocking water from supermarkets to increase their daily availability of water, while for lower income groups, as they say, the restrictions were a shock. Many people were sharing a connection of water, and therefore their consumption per household was quite limited. And then ultimately, if you look at the last top-bottom group, Filippi, there you can see a quote that says, "For us, every day is a day zero," to emphasize that in some areas of the city, water insecurity is not only caused by the drought, but is an everyday reality. The second dimension is procedural justice, and here I won't go into the detail of this historical overview, but what I want to highlight is that there is, throughout history or recent history, there is a strong that the white population have built and controlled not only the city, but also as part of these water services in the city for several centuries. During colonial time, the city was built under the idea of racial superiority of white populations, and therefore the concentration of infrastructures and services were in areas in which white colonial elites lived. This has been reproduced and even exacerbated during apartheid with additional intensified racial segregation and measures, which also created a situation where not only services are concentrated, but also economic opportunities, work opportunities in white areas, while indigenous areas were more peripheral. And the job opportunities were only coming from low-paid jobs from the center of the city. In post-apartheid, governments have tried to redress these inequalities, but with mixed results. For example, affordable housing has been a priority since 1994, but the valuable land, the central land, is already occupied, is already built up, and so much of this affordable housing is more peripheral and doesn't really allow for lower income residents to access the economic opportunities that would allow them to become less vulnerable socially and economically. So these vulnerabilities are definitely reflected in how the drought plays out in between 2015 and 2018, because the groups who are better able to respond and to adapt are also the groups that are politically more powerful in the city and in the country. The last element is a recognition of justice, and this is a study done by Elisa Savelli in 2023, where she has really focused on these elites, the ones that are that consume more water, but also the ones that are historically more powerful in the city of Cape Town. And it was interesting to see their perspective on the drought. As you can see from these quotes, which are quite strong and anonymous, there is this idea that the responsibility of the water crisis is with Black people, even though the majority or a little, at least lower income groups, largely composed by Black people, did consume very little water before and during the drought. But there is this idea that they have a culture of refusing to pay and that they require constant support by the government. And therefore, there is this tension and this conflict, still racial conflict, very strong, which shapes their interpretation of the drought, which is quite surprising, thinking of the fact that these are elites of the city, and as you can imagine, this type of households has a very high use of water compared to what an informal an inhabitant of an informal settlement will have. And so to conclude, a few ideas that are important to think about, a few lessons learned, I think. So elites have a very significant influencing power. Understanding their emotions or their perception is important, and because they have a power to shape how the city works and where the water flows. There is often this idea of capacity building or education for lower income groups in informal settlement to manage water. I think it's very important to direct a lot of this to elites, and in a way that there is a better understanding of where the challenges in management are. And related to this point, we found in a study that we published in Nature Sustainability, again led by Elisa Savelli, that overconsumption by the elites is as much a driver for water crisis in Cape Town as is climate change. So there seems to be too much focus at the moment in managing. There must be more focus on managing, water consumptions from the elites, because if the city focuses only on increasing supplies to avoid crisis without ensuring a more sustainable consumption of water in Cape Town, it will only reproduce very unsustainable practices. And finally, drought strategies should be more proactive, recognizing that gender, class, and race and other forms of inequalities play an important role in shaping who is vulnerable to droughts and their adaptive capacity, and that fundamentally reducing inequalities and poverty is a very effective measure to improve adaptation to climate change. And I'll stop here. Thank you very much.
Thank you, Maria. That was a fantastic talk and really, really thought-provoking. So we continue now on the theme of vulnerability and inequalities, and we move on to our last speaker for today. So Roman Hoffman is the research group leader for the Migration and Sustainable Development Research Group, IASA. His research focuses on the relationship between climate change and population dynamics, investigating the underlying causes, patterns, and consequences and types of migration. Please, Roman, go ahead.
Thank you very much for the invitation, and thank you all for joining us today. I will shift the focus a little bit more to the topic of drought and water stress and their impacts on human mobility and immobility. And specifically, when I will be talking about mobility, I will have a focus in the studies that I will present today, mainly on migration, but it is important to mention right from the beginning that also other forms of mobility can, of course, be affected in drought and water stress context. When you hear about the topics of environmental hazards and migration, then you may have come across media reporting like the ones that you see here on these slides, where the media often place a very strong focus on the numbers of people who may migrate in the future due to climatic change, due to environmental hazards they will be exposed to, as well as a strong focus on international migration. In my short presentation today, I would like to highlight that the topic of environmental change and migration is more complex than it is often portrayed in the public discourses, and that often we need to have a more nuanced perspective on the issue to really fully understand who is migrating, under which conditions, and under which environmental hazards. A couple of years ago, we have conducted a meta-analysis that illustrates this point very nicely. In this meta-analysis, we have collected studies that focused on the relationships between different environmental hazards and migration outcomes, both focusing on international and internal migration. What you can see here to the right side of the figure is the very different results that these studies have found. And what I want to highlight here is the sheer heterogeneity that you can see when we look at different studies and the results they produced on the impacts of environmental hazards on migration. So we immediately see that there is no deterministic relationships in place, and that households deterministically start migrating if they're exposed to a certain hazard. Instead, we see that local conditions and vulnerabilities play a very important role in moderating the relationship between hazards and ultimately migration outcomes. And what we also saw in this study is that it is less international migration that is affected and more internal as well as regional migration within a closer spatial range that is more strongly affected by environmental drivers as opposed to long distance, longer term forms of mobility. Building on this first study, we started looking more closely into the impacts of environmental hazards on internal migration. And this is a study I would like to talk a little bit more about here. In this study, which was published last year in Nature Climate Change, we looked at the impact of drought and aridity on internal migration, trying to collect a sample of countries that represent very diverse contexts. Here we built on a very unique migration database that my colleagues and I have gathered, which is building on data from IPUMS International, that is the Integrated Public Use Microdata Series, a data platform that harmonizes and provides access to census data from all over the world. Here specifically, we have used data from 72 countries that provide information on the current residents of census takers, as well as the residents of census takers 5 or 1 year ago. So we know in which regions, subnational regions, census takers have lived at the time of the census, as well as information about where they have lived 1 to 5 years ago for different subnational regions across the globe. You can see here the data set that we have compiled based on this information. In total, we have information for 72 countries and migration flows between subnational regions within these countries. Here you can see that exemplified for migration flows for China on the right-hand side. In total, we have information for about 1,400 different subnational regions, as well as migration between these regions over time. So here you see, based on the last census, actual data from China, where you can see the different flows of migrants between different subnational regions within the country. What is important also for our analytical approach is that we do not only have information at one time point, but really information about multiple periods. So here you see the coverage of our data over time for the 72 countries included in the data set. And what we do in our estimation is to combine this information on the impacts of drought and aridity on migration. We combine this information on the migration patterns with information about observed patterns in terms of drought and increasing aridity in the different subnational regions that we cover with our data set. Here we use monthly drought and aridity data at the subnational level, which we derived from the Climatic Research Unit of the University of East Anglia. And we built on 4 different drought and aridity indicators: the aridity index, the SPI in 2 versions, and the Palmer Drought Severity Index that was already mentioned also earlier today. And what we look at is we look at the climatic conditions or the environmental conditions 10 years prior to the census dates, and we test if the exposure to a drought in the subnational regions led to a higher outmigration from these areas towards other areas within a country. Our results, which you can see here displayed, the main results, which you can see displayed here in this table, show that we see significant and sizable effects of increased aridity and drought on migration, controlling for a range of confounding influences and also for potentially underlying time trends. In our models, we estimate that a 1 standard increase in aridity in a region leads to approximately 9.3% increase in the outmigration rate in that region. With our data, what is special is that we can also look at how drought and aridity changes in potential destination areas affects migration towards these areas. And what we can show here is that also in potential destinations, if there is a drought and increases in aridity, then we see a deterring effect on mobility towards that region, which is also quite interesting. So it's not only about origin, but also about potential destination areas. What is important is, which we then see in further models, is that the effects very much differ across different parts of the world. So we run a number of extended models where we looked at differences across different world regions and across different ecological zones across the world. And what we find here, and just to mention, these are only explorative models that combine some of our historical estimates with projected changes in aridity in the different parts of the world. What we find is that we see the strongest migration impacts in response to drought and aridity in Southern Europe, parts of Africa and the Middle East, South America, and Central and Southern Asia. And in particular, we see stronger effects in those areas that are characterized already by an arid and hyper-arid climate. So drylands are particularly affected by droughts and increased aridity, and where we then also see stronger responses in terms of migration for the local population. We further add to our subnational data set information about the socioeconomic conditions of the different regions that are affected by drought and aridity. And here we see some interesting patterns evolving, which I would like to briefly summarize on the following slides. So we see on one side that it's not necessarily the poorest countries where we see the strongest effects of drought and aridity on migration patterns, but we see somewhat that more middle-income countries and higher-income countries, that populations respond more strongly to these environmental hazards by changing their mobility patterns, potentially because they face fewer constraints in their mobility. However, when we look within the countries, we see that it's often the poorer areas within countries where people are moving out towards richer areas. I see that my slide just is not shared anymore, so I will share it now from my screen, and I hope you can see it. Apologies for that. It's coming back. Try again, share another time. Apologies for that.
No worries, Roman. Let us know if we can help from our end. We can see your slides now.
Now it's coming back, I think. Yeah, apologies.
Perfect. Thank you. No worries at all.
Unintentional. Okay, great. So what we have done on one side, we have further looked into agriculture dependency of the areas. And what we found is that migration responses to drought and aridity are, as we may expect, are stronger in more agriculture and less urbanized areas. So we see stronger effect in rural areas. And with our data sets, which allows us to kind of map out migration flows between different subnational regions, we can also look into mobility patterns of different population groups. So the census information also allows us to learn something not only about the overall migration flows, but also about who is moving by different age, sex, and education groups. And here we see interesting patterns evolving. And I would like you to focus especially on the top panel here, where you can see on one side that especially in lower income contexts, it is especially the better educated working age population, where we see greater tendencies to migrate, which also goes hand in hand with this explanation that I mentioned before, that they may face fewer constraints in their mobility, as well as potentially better prospects of moving. But we also see that large parts of the population are not at all affected by the environmental hazards or remain immobile, which may be for various reasons. And I just want to point out here that we see these very interesting differences between different population groups within the larger population, which are important to note. This very much links also to other research that we have carried out, and this is the last slide that I would like to show with content, where we have shown that it is really migration itself is just one among various adaptation coping strategies of households in the times of environmental stress. Many households actually remain immobile for various reasons despite environmental risks. And what is important is, and Maria has also highlighted that before, to see really the whole context of livelihoods and other adaptation options, as well as vulnerabilities that may shape to what extent households are exposed and vulnerable to a certain hazards and how they respond to it. I would like to close with the key messages that we do not necessarily, should not assume a deterministic relationship between drought and aridity and migration, but a relationship that is very much influenced by local environmental, economic, social, and political contexts. That not everyone moves, but that we see large differences between different population groups, and that a large part of people affected also by environmental stress remain immobile for various reasons. And then that we generally need to look at the broader livelihood context and other adaptation coping strategies when we talk about environmental stress and the consequences on migration. With this, I stop, and I'm looking forward to your questions and comments. Thank you.
Right. With that, I would like to welcome all of our speakers back to this virtual stage. Thank you all for such an incredible introduction to this topic. We're so glad to have you here today. We'll now be transitioning to the more conversational part of the forum. And as a reminder to our audience, you are welcome to submit questions to the Q&A box on the right of your screen, and we'll be moderating the questions for the speakers. And I just want to say, since the presentation section of this forum has gone on a bit long, we do plan to extend the forum by 10 minutes, ending at 11:40 for those of you in the Eastern time zone. As a reminder, this is recorded, so if you can't stay on, you can always go back and check the recording later. But still, since we will probably not get to all questions, I would like to encourage our speakers to go ahead and answer questions in the chat if you feel able to do so. I know that's already been started, so thank you. And I think for both speakers and our audience, you have the ability to upvote questions that you feel are especially interesting. Okay, with that, I would like to take the moderator's privilege here and start off with a few of my own questions. Bridget, starting with you. I thought your quoting of the World Bank's report on groundwater being a buffer for climate extremes is really interesting. But some of the regions you shared were showing like a pretty frightening sort of trend of groundwater not recharging. And so I wonder if there's a sense in that some regions of the globe, groundwater is sort of falsely propping up a delayed catastrophe that we're going to have to deal with at some point. So I was wondering if you could speak to any potential solutions in these regions where groundwater is overexploited.
Right. Well, I think the media emphasizes a lot the overexploited areas, and I don't think the media really covers the underexploited areas. And I think that's what the World Bank report did. And so these small basement aquifers on top of basement are thin, small, and so there's not much to overexploit. So they're self-regulating. So that was the main point I wanted to make. So we need to change the messaging to say, I think as a number of speakers have emphasized, one size fits nobody. and we need a much more nuanced approach. And so these small basement aquifers, 40% of sub-Saharan Africa is covered by these basement aquifers that the British Geological Survey mapped. And so I think we need to exploit those a lot more. And as other speakers have talked about, cities often turn to groundwater during drought crises, Cape Town, Sao Paulo, and other regions, but we need to manage it better. And Chris is from California now. They have the Sustainable Groundwater Management Act. And so we need to be more diligent about managing it. But there are areas where we can expand usage, and we need to change the mantra of everything is overexploited.
Thank you. That was excellent. Chris, moving on to you. I wonder if you have any sort of follow-up insight here to share on using drought forecasts, which you talked a lot about, to reduce pressure on potentially vulnerable groundwater resources.
Yeah, thanks, Abigail. I think it's really important to understand that at a lot of places, what we're experiencing is both more intense droughts, but Pakistan and talking about the increasing volatility there. We're certainly seeing that in East Africa. And so, interestingly enough, the total water storage, the subsurface water in East Africa is going up, even as the overall precipitation is going down because of the impact of these really extreme precipitation events. So, through a lot of different techniques, large-scale irrigation, small-scale water storage, sand dams, which trap the flow of evanescent streams and try to get the moisture to percolate down to the area, the groundwater in places like Somalia. There's lots of different strategies that we can do to try to store more extreme water. And then during a drought, there are technologies like micro irrigation or trying to amend the soil to store water better that we can do. So there's quite a bit that can be done.
Thank you. That's really encouraging to hear, and it's nice to have some specific examples. Luxon, moving on to you. I really appreciated your focus and emphasis on sort of the interconnected nature of all of these global challenges, and you focused on sort of the water, food, energy nexus. I was wondering if you could give a sort of a specific example of some of these transformative circular approaches to these nexus challenge. As you mentioned, climate smart agriculture. I was wondering if you could go a little bit more specific about what that might look like in South Africa or in other settings.
No, thank you, moderator, for such a question. And I think the previous speakers almost touched that question. But yeah, Abigail, the challenge, of course, I mentioned of trade-offs and the synergies. There's water scarcity. In my presentation, I spoke of almost over 600 people will be living in water scarce regions. And of course, the solution at the moment is to use groundwater resources. But in my region, these groundwater resources are not measured. So we don't know how they are being depleted at the moment. So that's a trade-off. Almost every household in urban areas at the moment has a borehole, and they are using groundwater resources. And recently there was a publication showing that some cities are sinking on an annual basis, 1 centimeter going down, and one day you just wake up, your house is slanting at an angle of 60 degrees, and your furniture just starts falling. You wonder what is happening because it's not controlled. So those are some of the synergies. Those are some of the issues that we need to look at. and I'm told Tokyo, so the article was saying Tokyo was facing these challenges some decades ago, but they are now controlling groundwater use as well. So we needed to identify when we are extracting groundwater resources, we shouldn't focus only on water supply, but we should also look into other effects. That is where the transformative approach comes in. Let us not focus on one area only, but let us look into the whole perspective. Thank you so much.
Thank you. That was excellent. Maria, jumping to you, I thought your talk was an excellent follow-up for Luxon's. They paired together really well. I thought, as sort of setting the scene for the emphasis on social sciences, you focused mostly on the city level, but I wondered if you might be willing to sort of expand a little bit, given that many of these challenges are transboundary, international, both water resources and droughts impacting many nations at once. I wondered if you might be willing to apply some of your insight to sort of international collaboration or perhaps lack thereof, and what might be your recommendations. Oh, I think you are still muted.
Thank you for your question. I don't know how well I can answer that. I'm sure there's people who can do it better, but I can give some ideas. There is one element that I think that is common in the dynamics that you see at city level and at maybe international, or let's say top transboundary level, that there is some states and some actors that are better placed to negotiate how water resources are shared, whether that's groundwater or whether that's surface water. What we see today is that there are over 300 transboundary resources that are shared, and less than half have a treaty that sort of regulates the way the water is shared. And within those 50% that have treaties, not all the treaties, evidence shows work equally well. So those who work at this level often suggest that talking about water wars is perhaps too dystopic and not really reflecting current reality. There is a lot of room to intention and willingness to cooperate on sharing international resources, at least at the level of sharing information. But as Luxon was saying, when it comes to more, more significant levels of cooperation, many rivers still lack agreements and lack tools to peacefully share those resources. When it comes to thinking about power relations, yes, this remains an issue. Hydrohegemony is a concept that has been developed by colleagues Werner and Mark Zeytoun, who indeed emphasize how some countries are better placed to close deals that are more favorable to their own country than other countries, and that obviously does not, in the long term, does not facilitate inclusive and sustainable collaboration between riparian states.
Thank you. I appreciate that. I was asking a bit of a jump, and I really appreciate your insight there. Roman, you also talked about transboundary issues, focusing on migration. And I wondered if you might be able to sort of bring us full circle, thinking a little bit about groundwater again. And again, this is asking a bit much perhaps, but I wonder if you could comment on, like, is groundwater a buffer here? Groundwater resources, perhaps a buffer to reduce strain on those migration pathways, and how that might play into this. Have you looked at all at groundwater exploitation as a moderator on migration?
Yeah, thank you very much for this question. So this is actually something we are currently looking into, and we haven't done that in the previous studies where we have really tried to look at different elements of water stress, drought, and then migration outcomes directly. But we have now started increasingly looking also at the impact and the role of groundwater levels. and how they can moderate these relationships, serve as a buffer. And my intuition would be that they play an important role in these contexts as well. Some of the colleagues online have commented also, like the water management, of course, also linking back to some of the other presentations, that can play an important role. To what extent households have possibilities to adapt and cope with environmental stress within their locations, or whether they are forced or decide to move out of these contexts. So we're looking into this, and I hope to be able to say more about this maybe at our next seminar forum that we organize on the topic.
Excellent. We're excited for that. We'll pay attention. Moving on to some of the audience questions here. I think this one is for you, Bridget, from Ben Moswote from Sub-Saharan Africa. With regard to Sub-Saharan Africa, while there is an immense groundwater potential as a resource, we've been talking about this in the last couple of minutes, has surface water been fully exploited, given that the cost of exploiting groundwater resources is relatively prohibitive compared to harnessing surface water? So this one, I'm directing at you, Bridget, first, but Luxon, maybe you might be able to jump in as well.
Again, I guess it would depend on the local conditions, and probably they could exploit more surface water. People often irrigate adjacent to surface water bodies. They call it spate irrigation, and then they have pipelines. So people are accustomed to either using surface water and groundwater, and it's difficult for them to move from one to the other. So I think there's opportunities for both. And as Chris mentioned earlier, sand dams and other things can hold up. The challenge is managing the extremes, the droughts and floods. And if we can recharge the groundwater using some sort of managed aquifer recharge or sand dams, then that surface water could recharge the groundwater and be available more widely. What we have seen in different regions globally is that groundwater is more accessible, more widespread, and so it's easier for people to drill a well and access groundwater locally. But we need expertise also, because the types of aquifers they have in Africa are difficult to explore and exploit. And we need geophysicists like people like Paul Bowman and others helping NGOs to increase the success rate for groundwater development. So conjunctive use of surface water and groundwater is the best option. And we need to be moving in that direction. And I think different ways of doing that.
Any additional insight here, Luxon?
Yes, just to add to what I cannot agree more to what Bridget has just said. Yeah, I can give an example. South Africa and Zimbabwe, for example, in my region, they are the most dammed countries. Actually, South Africa no more has space to build more dams. However, in the case of Zimbabwe, for example, yes, surface water resources are available, but they are not accessible. Taps have run dry, so people end up drilling boreholes. But there are also hygiene issues, sanitation issues associated with that. But the most important thing is to quantify those. How much groundwater resources do we have? How much those aquifers contain, and how much are we depleting them? And how much are they recharging? So with the drought and so forth, I spoke of sinking cities. So let us look at these issues from a secular model perspective. But yeah, groundwater resources are being exploited. Conjunctive water use is the option. But let's take, for example, the DRC, Democratic Republic of Congo, can supply the whole African continent. But not all households in the DRC have water resources. So it's about availability, the difference between availability and accessibility. Thank you.
Thank you. I think we have time for maybe 2 more questions. This one I'm going to throw at Maria first, but anyone else is willing to jump in. This one comes from Andrea Galetti. I'm sorry if I'm pronouncing this name wrong. Drought is now threatening historically water-rich areas. in these places, water stakeholders and politicians are even less educated towards the concept of water security. So instead of using their advantage to mitigate and prepare, they will have to adapt, perhaps when it's already a little bit late. So the question is, what scientific approach or evidence is best to make stakeholders and politicians more aware and willing to be educated about sustainable water use?
Yeah, thank you very much. That's a good, very interesting question. I think in your question, there is already a part of the answer, which is there is a need to learn from countries who have already experienced significant droughts, and understand which measures have worked in these countries and which instead may not work. And with that, I don't mean just transferring what has been done in one city to another, but thinking what is transferable, what reflections to are relevant for other cities. I think there's a few things that I've been looking at that I think are quite interesting. There is much more research around co-producing knowledge, water knowledge, and co-producing solutions with communities and local authorities. And I think there is many more research, at least within in the social science, but also actually within hydrology. And there is a group I'm part of, which is called Co-producing Water Knowledge, and it's part of is led by a hydrology society. I know Julia is there. Maybe if I said it wrong, you can correct me in the chat. So co-producing knowledge means that we would have a better understanding, but also develop solutions that are locally more relevant, and that therefore can be more effective and more implementable. So that's really an important aspect. And in this, I particularly like the work that has been done by Mark Pelling and colleagues around also thinking about aspirational futures and involving communities, not only to address a particular problem, but think what type of future they envision in response to droughts or in response to floods, what type of future they envision for the city, and see what is feasible and implementable beyond the immediate solution of a drought, but also in terms of how we reimagine our cities in a more inclusive way in the context of climate change.
Thank you. This is going to be the second to last question here, and I will try and keep this actually the second to last question. Here, the sort of big, I think this is on the popular mindset a lot too, is to what degree could water or the lack of it, water scarcity, cause the next global conflict? Perhaps to what degree is it already causing conflict? Roman, I'm going to toss this one to you first, but again, anyone is welcome to jump in.
Yes, thank you for the question. Of course, water scarcity is a factor that can raise tensions. Ourselves, we have not done distinct research on this topic, so I don't want to dive too deeply into that. But we see, of course, that conflict also when we talk about impacts and the exacerbation of impacts of other environmental stresses can be very relevant factor. Also, when we look at human mobility at large, can make populations more vulnerable, can trap populations in place, and can also be a reinforcing factor when it comes to migration. So I think it is an important part that we need to also consider when we're having this discussion, and to not only look at, as I said, like these environmental hazards in isolation, but to understand them in a broader context of other stresses that people are exposed to, as well as vulnerabilities and capacities that they have. And I think this is important to get this holistic understanding of these processes.
Thank you. Appreciate that. All right. So the last question is, I'm hoping to get insight from everyone here. It's a big one. It's a broad one. There might not be a correct answer necessarily. But the question is, what is the best global policy instrument for managing drought? From Danielle at Segai. Again, sorry if I pronounced that incorrectly. So does anyone want to jump in first?
Best is relative. Best is relative. So to mention, you say this one is the best. It's quite difficult, but I leave to others. But best is relative.
Well, also, I think most of the speakers today were emphasizing the nuances with the many different issues. So as I said earlier, one size fits nobody. There's no global. It depends on the local conditions and regional conditions. So, and Chris was mentioning, being prepared and having advanced forecasting helps reduce the impacts and really, I guess, developing resilience in the long term, regardless of whether you're in or out of a drought, because the psychology is when you're in a drought, you think you're never going to get out of it. And when you're out of it, you think you're never going to have one. So I think building long-term resilience in the infrastructure and other things and social and infrastructure would be helpful.
So long-term thinking, not thinking global, but thinking regional or local. I think those are two very insightful points when thinking about this broader topic. Chris, I saw a hand from you.
Yeah, very quickly, reducing greenhouse gas emissions is something that seems to be forgotten these days, but that's a huge important thing if we want to reduce drought.
I think that's an excellent point as well. Thank you. Again, a big picture, interconnected global crisis response. Well, this has been a really, really excellent day. I've so enjoyed hearing your answers and your talks. It was really thought-provoking. Thank you. I would like to give the opportunity for any final remarks if anyone has final insight to share. Not seeing anyone jumping up and down. So I'll just end with a huge thank you again. A great discussion. Thanks again to Camilla and Lou, my fellow moderators, and Sarah and Lauren, who have been working behind the scenes here. The recording will be available soon on the CellPress Sustainability Hub, and the link will be sent out when it's ready to everyone who registered for the forum. For the audience, thanks so much for watching today. Thanks for some excellent questions. I hope they were mostly answered in the discussion or in the chat. A brief reminder that I believe there will be a survey sent out via email just to get your feedback on the event. And we hope to see you at the next Sustainability Forum. Thank you.
Thanks.
Thank you.
Thanks, Abigail.
Thanks,
Thanks,
everyone.
everyone.
Thank you. Have a good day or morning or evening. Bye-bye.
Likewise.